Everything we know today, time, space, stars, planets, and us, all of it traces back to a single point. According to scientists, the universe formed approximately 13.8 billion years ago. This conclusion is supported by independent yet consistent lines of evidence, such as the cosmic microwave background radiation, the rate at which galaxies are moving away from each other, and the observed ratios of chemical elements. We call this beginning the Big Bang. However, there is an important misconception that needs to be corrected. The Big Bang was not an explosion that occurred within space. It was a process in which space itself began to expand. In other words, the universe did not explode outward from a central point. It expanded everywhere, in all directions, at the same time. At the moment of its beginning, the universe was extremely hot and extremely dense, and its size was smaller than the scale of subatomic particles. Time and space began to have meaning precisely at this moment. The physical laws as we know them also started to operate from this point onward. Within a tiny fraction of the first second, the universe expanded at an extraordinary rate. This period is known as cosmic inflation. It is one of the strongest models explaining why the universe appears nearly the same in every direction. As the universe expanded, it cooled. As it cooled, energy transformed into matter. At first, quarks, electrons, and neutrinos formed. Later, quarks combined to create protons and neutrons. After approximately 3 minutes, the universe contained hydrogen and helium nuclei, but it was still dark, because light could not yet move freely. About 380,000 years later, atoms formed. Electrons bound to nuclei, and light was released for the first time. The cosmic microwave background radiation that we can still measure today is the remnant of that moment. This light is the oldest directly observable evidence of the universe. When light was released, the universe was still very simple. There were no stars, no planets, and no galaxies. There were only vast clouds of gas made of hydrogen and helium. At this point, gravity entered the scene. Matter was not distributed perfectly evenly throughout the universe. There were very small differences in density. Gravity gradually made these denser regions even denser. Over millions of years, gases collapsed and compressed. Temperatures rose, and eventually the first stars of the universe were born. These stars were extremely massive and incredibly bright, but they lived very short lives. Yet they carried out a critical role for the universe. Inside their cores, elements heavier than hydrogen and helium were created: carbon, oxygen, silicon, and iron. When these stars died in supernova explosions, they scattered these elements into space. This is a scientifically established fact. Every heavy element in the human body was formed inside a star. In the most literal sense, we are made of stardust. Thanks to these explosions, new stars, planetary systems, and galaxies began to form. However, the universe is shaped by more than just the matter we can see. Dark matter, which allows galaxies to remain bound together without flying apart, has been proven to exist through observations, even though its true nature remains unknown. There is also dark energy. This mysterious energy causes the expansion of the universe to accelerate rather than slow down. This discovery was confirmed by supernova observations made in 1998. Today, the composition of the universe is approximately 5% normal matter, 27% dark matter, and 68% dark energy. In other words, most of the universe is still made of things we do not yet fully understand. Approximately 9 billion years after the Big Bang, the universe had developed complex structures. And about 4.6 billion years ago, in an ordinary arm of the Milky Way galaxy, an ordinary star was born, the Sun. From the disk of gas and dust orbiting the Sun, planets formed. One of these planets settled at exactly the right distance. Earth. Earth had liquid water. It had a magnetic field. Its atmosphere was capable of protecting life. Under these conditions, life emerged. Simple chemical molecules gradually turned into complex structures. Single-celled organisms evolved into multicellular life. And eventually, a species capable of thinking and questioning appeared. Humans. The stars we see in the sky today are actually images of the past, because light takes time to travel. Some stars are seen as they were millions of years ago. The universe is still expanding. Galaxies are still moving away from one another. and scientists continue to try to understand the future of the universe. But the most striking fact we know right now is this. The universe began lifeless, yet today it possesses a consciousness capable of understanding itself. And we are not merely spectators of this 13.8 billion-year story, we are a part of it. Perhaps the most intriguing question about the universe is not, how did it form? The real question is this. Why did such a vast universe evolve in a way that allowed thinking beings to emerge?